Samik Bagchi is the Director of Innovation for Digested Organics. You'll notice that he is board certified as an environmental scientist with the American Academy of Environmental Engineers and Scientists. His specialty is in environmental microbiology. And today, Dr. Bagchi is going to be speaking with us about innovative membrane-based approach for high-strength industrial wastewater reuse. Samik, the stage is yours. We're ready for your presentation.
Thank you, Dan. I really appreciate your nice introduction, and thank you everybody for joining the Pechachka. Today, I'm going to talk about the often overlooked side of the wastewater treatment, that is the industrial wastewater treatment, and how we can make it a zero liquid discharge facility. So just to give you an idea, we had an industrial wastewater that was like 800,000 gallons per day that was generated in a facility which was making some fermentation. And it was really high strength because we had more than 30,000 gallons, 30,000 milligrams of liter of COD in it. So why go for zero liquid discharge? Because it reduced the cost, and decentralized wastewater treatment is the new approach for fundamentally changing how we look at the industrial wastewater treatment. And that's the objective for us to kind of like go for how we can make it a JLD facility. So Digested Organics is a industrial filtration company, and our approach was based on the filtration. And we wanted to actually introduce innovative approach to kind of like do the JLD. And this is what I'm going to show you here. So initially, we did a lot of intensive piloting to kind of see what can work for this system. And first, we tried some dewatering process using a dissolved air flotation or centrifuge. None of them really kind of worked because you need either polymer, the dewatering was really not good. We used some stainless steel ultrafiltration system, which was working, but it's really expensive because the stainless steel itself is a very cost intensive process. So that was not really working. So we did some further research to find out what can work really best for it. And we thought like, let's go to the basic, just go for a simple self-screen kind of like process, just to take anything large solids out of the system, and then go for our innovative filtration system that we call Superfiltration. So our colleagues actually came up with the idea of Superfiltration, which is in between a tight ultrafiltration and a loose nanofiltration, pore size of 1 to 1.2 nanometer, and it is a molecular cutoff limit of like 500 to 3,500 kilodalton. The uniqueness of this membrane is that it's really low fouling, and it has a unique polymeric chemistry to make it handle really high solid and high COD wastewater. So this was really good for this kind of high strength wastewater application. So we went for like pilot testing with that in our site. We did like more than 3 months of testing with this system to kind of like fine tune our process. And as you can see in the right here, you have really high strength wastewater, and you're getting a good clean quality of the permeate out of the superfiltration. And also our pilot testing showed that you can have a repeated good performance over a period of time. And we tested it for like 3 months time, and it actually had a really good cleanability, and it was the permeate recovery, and the flux was consistent over the period of time. So it was really working well, and we are getting a really good quality permeate and really high concentration of the solids out of it. So this is the solids that's coming out of the system, and it is like more than 10% solid as a concentrate. So you can imagine like how much solid it's coming out just by this first filtration system. So after this process, we went for the RO to kind of further filter the system. And what we had there was a sub-induction RO system, which is a unique RO to kind of like deal with this really high strength wastewater. And it's a kind of repeat batch process to kind of like get a very good recovery and consistent process parameters without fouling the membrane. And this is what we have achieved through this sub-induction RO process. And we really got like good, clean quality RO permeate of this process there. And as you can see here, like the clean water in the middle is the RO permeate, which was really clean, but it still had like almost 800 milligrams of COD coming out from this 30,000 milligrams per liter of COD in the feed itself. So we did some further cleaning with a brackish water RO or polishing RO to really clean it to the quality so that that can be reused on site in the industrial facility for different other purposes. And all the concentrate that was coming out of this whole process was kind of used for making dry solid that can be utilized as a feedstock for animals. So what we did vacuum evaporation of the concentrate that's coming out of all the different filtration process, and that makes a dry solid that can be sold as an animal feed. And so overall, our approach was to kind of like have first screen through superfiltration to polishing RO to get a reused quality water, which was 80%, and then all the solids kind of make an animal feed and make it a completely zero liquid discharge facility. So this unique process, we are currently building the full scale, and it will be operational in by the end of this year. And the dry product that we are gonna use as a animal fertilizer from this process, and 80% will be the recovery of water. And I'm really excited to share with you. And if you need any further information about our system, please contact us. We'll be happy to answer how we can uniquely kind of work with you to make your facility a zero liquid discharge facility. Thank you.
Fantastic. Well done. Well done. I think we all owe you a round of applause for that, right? Kind of feels weird to try to pull everything together. It's like putting on clothes that belong to somebody else, right? It's like a little bit the wrong size. So I see some questions coming in. I've got a few to ask you as some are coming in. What is that yellow color? What is that all about? Anything you can tell us?
Yes, so yeah, definitely I can tell you. So it's coming from a fermentation process, and the unique application is that, so they have a process where they use bacteria to make like a fiber, and that fiber be utilized as a alternative for silk and all this. So they actually make fiber out of the bacteria. So all this yellow thing is actually the digested of the bacteria. So they kind of like, homogenize the bacteria and all the fermentation byproduct, everything, and that's their wastewater.
Fantastic. Now,
yeah, it high quality, high COD. It's kind of really unique.
It makes sense. Now, it looks like it's going to be a fairly energy-intensive process. So help us understand the trade-off. I mean, you're trying to capture zero liquid discharge, right? So there must be some driver there that's making it worthwhile to have such an energy-intensive process. Help us understand that trade-off.
Right. So like many of the industries, like the facility is in a place where if you have to go for like a discharge into the municipality, first of all, they didn't have enough capacity to kind of like run their whole wastewater out of their system for the industry. And then the surcharge that they will apply for this particular process will be so high. And then apart from that, with all the like other processes like involving the stakeholders from the community and making sure how comfortable the community is with like unique wastewater discharge, with like some kind of notion that it's a unique bacteria, makes it really challenging for the industry to go for it. So they kind of felt like it will be much more like future oriented to go for the JLD rather than like, going for discharge.
Makes sense. Makes sense. Now, thinking about the whole process and kind of taking a step back, you've covered kind of what's going on with the liquid, but how about the air, the odors that are coming off? Is there air, are there air permitting? How do you blend that in? Is that something you can speak to a little bit?
The air permitting is definitely the one side that we have been looking at, like, all the VOCs and how that can be managed. And there are some air scrubber, and it will be a content facility, but there is like more going on that, like, in terms of how we can capture if there is a VOCs. But most of this is a filtration process, so it's a closed system. The only process where there will be like an open is like the equalization tank on some other places. So most of the cases, it's like, it's the whole VOC is going to be get captured inside the system. But there will be definitely monitoring future, like the plant will be running by end of this year. So then the permitting and everything will become into contract for that.
It'll all get very serious very quickly, won't it?
Yeah.
Well, thank you so much for being our first Pachachka presentation. Once again, congratulations. Thank you so much. Thank